Hi, welcome to myprojectbazaar.com. Your requested paper is Secure kNN Query Processing in Untrusted Cloud Environments. Let's move on abstract. The objective here is to allow a querying user to retrieve nearest neighbor among a set of public points of interest without revealing location to the location-based services. The first approach is to use clocking regions. In this paper, we propose a family of techniques that allow processing of NN queries in an untrusted outsourced environment, while at the same time protecting both POI and querying users' positions. Users send their current location as the query parameter and wish to receive as result nearest neighbors. But typical data owners do not have the technical means to support processing queries on a large scale, so they outsource data storage and querying to a cloud service provider. Many such cloud providers exist who offer powerful storage and computational infrastructures at low cost. However, cloud providers are not fully trusted and typically behave in an honest but curious fashion. Specifically, they follow the protocol to answer queries correctly, but they also collect locations of the point of interest and the subscribers for other purposes. Our techniques rely on mutable order preserving encoding, the only secure order preserving encryption method known to date. We propose the Voronoi diagram kNN method for secure NN queries, which works by processing encrypted Voronoi diagrams. The method returns exact results but is expensive for k greater than 1 and may impose a very heavy load on the data owner. To address the limitations of Voronoi diagram kNN, we introduce triangulation kNN method that works by processing encrypted delay triangulation, supports any value of k and decreases the load at the data owner. TKNN provides exact query results for k equal to 1, but when k greater than 1, the results it returns only approximate. However, we show that in practice the accuracy is high. We outline a mechanism for updating encrypted Voronoi diagrams and delay triangulations that allow us to deal efficiently in an incremental manner. We also provide performance optimizations to decrease the computational cost inherent to processing on encrypted data, and we consider the case of incrementally updating datasets. We present an extensive performance evaluation of our techniques to illustrate their feasibility in practice. In the next flow of the project, first is dataset extraction. Dataset extracted by the data owner, and the clients have to send the encrypted location point to the data owner. Data owner receives the encrypted query point from the client. Based on the encrypted query, he will transfer the encoded location point to the cloud server. Here, cloud server receives the encrypted location point from the data owner and receives the query point from the client. And the next process, secure range query processing. Processing kNN queries or encrypted data requires complex operations such as secure range query processing. Next process, generating MOP tree. MOP allows secure evaluation of range query processing based on mutable order preserving method. MOP is an order preserving encoding. It can be used to answer securely range queries without need to decrypt ciphertext. And next process, finding kNN nearest neighbor based on two methods. First one is Voronoi diagram and another one is the delay triangulation kNN. We employ Voronoi diagrams which are data structures successfully designed to support NN queries. In our system model, both the data points and query points are encrypted. We need to check the enclosure of a point within a Voronoi cell securely, and based on the encrypted location point and data point, we are generating Voronoi diagram. And the next process is delay triangulation, and based on the location point and encoded query point, we are generating delay triangulations, and we are evaluating the performance of both VDKN and DTKN, and based on the VDK and DDKN, we are getting the result and sending the result to the client. Client getting the location result point from the cloud server, and we geocode the location point, and finally evaluate the experiment based on response time and query encryption time. Next, execution of project. Before starting execution, we have to create folders for three actors: client, cloud server, and data owner, for storing files of encrypted and encoded query points. And we start execution. The project title is Secure kNN Query Processing in an Untrusted Cloud Environment. By clicking on the title, you can proceed to the execution. This process dataset extraction. We have to load the location dataset, and we can view the original dataset here. And the next step is a dataset extraction. Dataset extraction done by dataset owner. First we have to load the location dataset, and by clicking extract button we can insert the records into the database. Record inserted successfully, and we can view the inserted records here. And the next process, receiving encrypted location query from the client side. For this we have to run the client. Client have to give the information of client, an IP address, MAC address, and system name, and select the operating system. And client have to enter the current location as the request to the dataset owner. Location, landmark, and city code, state code, and zip code, and getting the private key for the client. And by clicking submit button, information added into the database successfully. We can view the details here. And by clicking write to file button, these details are written to the file successfully. We can view the file details here, and we can also view the file in client side location request file. And the next process, encryption. For this we have to read the location request file which already we entered. You can view the file details here, and generating key for encryption. By clicking encrypt button, file will be encrypted. File encrypted and written successfully to a file, and we can also view the file in encrypted location file. And next process, sending this encrypted location to the dataset owner. For that you have to load the encrypted location buffering, and in data owner side we have to select the receiving path which already created, data owner folder, and start receiving, starting, running and receiving file, buffering and connection to the server, file sending and receiving data in dataset side, and saving file, file received, and file transferred. And we can view the transferred file in data owner side which we send it from client side. And here in data owner side we have to get the encrypted file which receive, and get the generated key for decrypting the file. By clicking the decrypt button, file will be decrypted, and we can view the original file here. And the next process, transfer encoding location points to the cloud server based on encrypted query location. First you have to get the encrypted file. When we can view the file path here, and we are encoding the points based on encrypted location, and we are writing the points to the as file encoded successfully. And we can view the file in data owner side, encoded points which we generated. Next we have to send the location points to the cloud server. Before that, client have to send the query point to the cloud server. For that, client have to enter the query point, and we have to encrypt the query point. File encrypted successfully, and file written successfully, and load the location file and send to the cloud side. Further, here we have to run the client's cloud server. Cloud server receiving the location points from the data owner and query points from the client side. Select the receive path which we already created as a cloud server folder, and start receiving. Before that, load the encoded points, buffering here, started owner, starting, sending and receiving file, buffering, connection to server, file sending, file transfer finally. And we can view the transferred file in data cloud server side. We can view the received file in the cloud server, which we sent from the data owner. And next process, send the location encrypted location query to the cloud server. For that, how to load the encrypted query, which already encrypted. And here we have to select the received path at cloud server and start the process. Sending and receiving file, and here connection, file sending and receiving, file transfer successfully. We can view the file in cloud server side. This is the encrypted query which we sent from the client side. And we can view the encoded point received from the data owner, and we can view the encrypted query received from the client. And next process, range query processing. For this, here we can view the encoded data points and value for the data point, and here we can view the encrypted query and generated query point value for the encrypted query, and encoding the query points by clicking encode button, and by clicking right button, file rated successfully. By clicking save button, file saved into the database, and we can also save the encoded query points to the database. And we can view the data points here, we can view the query points here, and we can view the range query processing for generating MOP table, and next process generating mutable order preserving encoding table. Here first we have to click, by clicking fill MOP step 1, we are filling the values for step 1 and step 2, and we can draw the tree here, and by clicking fill MOP3, the values will be added into the tree and tree will be updated. The next process, finding kNN process. To search the kNN for the query point, we have to get the data points by clicking get button, and we have to get the query points. And we have two methods for finding the nearest neighbor search. First one is Varna diagram and another one is real triangulation diagram. Both are generated based on encrypted data points and query points. First one is Varna diagram. Here we are generating Varna diagram based on encrypted points. These are generated based on encrypted points, and we can also regenerate the Varna diagram. And here we can view the performance of the Varna diagram and starting time for generation and generation time of Varna diagram based on encrypted points, and time to encode the Varna points and processing in elapsed time. And we can get back to process the data triangulation. For that we have to get the points, data points and query points, and we can move on processing with tree triangulation method. For here, tree triangulation diagram generated based on data point and query point. You can also generate the tree triangulation. We can also view the performance of the triangulation diagram. Same as starting and generation time of tree triangulation, time to encode the Varna points and processing time and elapsed time. And next we can view the performance map for the delay triangulation method. Here we can view the points map generated successfully, and we can also change the color and regenerate the points map, and color will be changed successfully. And finally we are returning result to the client. For that we are getting the encrypted query. Based on the encrypted query, we are getting the location points XQ and YQ, getting the XQ and getting the YQ, and we are saving the file saved successfully. And we can view the encrypted and points here. And next we have to send the file, that is result point, to the client. You can open the file, and in client side For receiving, you have to select the received path, which we already created as client folder, and starting server, running and using file, referring connection to server, file sending, receiving, saving file transfer successfully, and we can view the file in the client side, and we can get the result point which we send from the cloud server. And here client can view the result from point XQ and YQ by clicking view result button. Can view the result. We can also nearest neighbor based on the encrypted query, and here getting the result based on the encrypted query, and we can also review the land ID which we entered for the location request, and we are getting the location result as a geocoding kNN location result. Here we are getting the result points, and we can view the coordinates which we based on moving the mouse, and we can draw the grid, and clicking draw point we can view the draw point, and getting the exact result as longitude and latitude, and by clicking draw icon button, points are geocode the kNN location result accurately. And finally, we are evaluating performance evaluation based on the response time and data encryption. Based on response time, we can view the result here. Based on encryption time, we can view the result here. And next, performance evaluation based on Warner diagram, and we can view the response time map here, data encryption time for the Warner diagram, and finally, we can view the overall performance evaluation for the kNN query processing method. Thank you.